Good day, doctor. My name is Ong Hong Kai and my metric number is 286142. Today, I would like to present my individual assignment to doctor through this video. My assignment title is TikTok Data Analysis. Next, I will talk about my data acquisition. For this assignment, I acquired the TikTok Trending Tracks dataset from Kaggle. The dataset entitled TikTok Trending Tracks encompasses a total of 23 features, including track ID, track name, popularity, and more, as illustrated in the screenshot on the left. It contains 6,746 instances featuring a diverse range of numerical, non-numerical, and categorical data. Now I will proceed with my Google Colab presentation. First, I import the pandas library and use the read CSV function from pandas to read the contents of a CSV file named TikTok CSV and store it in a pandas data frame DF. For my data preprocessing part, I use drop and A and drop duplicates methods to remove any rows in the data frame DF that contain missing values and duplicate values. Besides, a list name columns to delete is created, which contains the names of columns that are irrelevant for data analysis, and drop method is used to remove them. Next, I convert the release date to year in order to simplify my analysis and provide a clearer view. I install an upgraded scikit-learn library. Next, I created a popularity binary variable and set a threshold value equals to 60. It assumes that tracks with popularity score above 60 are considered popular, and those with a score of 60 or below are considered not popular. Next, the code uses the panda library group by to assess the balance or imbalance in a binary classification in popularity binary column. It groups the data frame by this binary column 0 and 1 and store the resulting counts in an array named balance count. After running, the outcome shows array 2456 and 2189. This shows that 2456 is for the binary 0, whereas 2189 is for the binary 1, which may be considered as balanced. Next, I define two colors and plot the dataset distribution by popularity using plotly. The blue bars represent not popular, while the gray bar represents popular. Here is the outcome. As we can see from the graph, I use matplotlib and seaborn to plot the number of songs, tracks released each year with years on the x-axis and the corresponding tracks counts on the y-axis. Let's see the outcome. From the outcome, we can see that the trend is almost the same from 1986 to 2010. It starts to increasing starting from 2010 and increase significantly on 2018 and 19 and reaches the maximum on 2020. Shows that the tracks are being released the most on 2020. However, it drops drastically after 2020. Next, I am plotting the trend for each genre using group by and seaborn SNS line plot 2. Let's see the outcome. As we can see from the graph, there are 4 lines in the graph, which are TikTok Dance, TikTok OPM, TikTok Philippines, and the last one is the red line, but it doesn't show in the legend. Overall, the trend follows the previous trend, which reached the maximum at 2020 and then dropped drastically, except for the red line, which is underscore TikTok. I also plotted the popularity bar chart with respect to the artist name. As we can see from the bar chart, the highest popularity is owned by Lil Nas X, followed by Justin Bieber and BTS and others. Next, I also plotted the highest value of track names obtained from the dataset. As we can see from the bar chart too, the highest value is number 8, owned by the Blinding Lights, followed by Dance Monkey with 7 value and the others. The next part is performing trend analysis and make future predictions on the number of track released each year using a long short-term memory LSTM neural network, a type of recurrent neural network RNN. The code first aggregates the data by the release year, normalizes the track count data using min-max scaling, and prepares the data for the LSTM model. The LSTM model is then constructed with 2 layers of LSTM units and a dense layer, and it is trained on the prepared data. The trained model is used to predict the number of tracks for future years, and these predictions are inverse transformed to the original scale. In my LSTM model, I decided to put the epoch as 100. Means it runs 100 times of epoch. Next, I can set the number of future years based on my analysis needs. In this case, I set the future years as 5 years. So now let's run this code. After running 100 times ePoach, then I can get this type of graph. It will be the extension graph for the previous trend analysis graph. For example, the previous trend analysis graph is until 2020. In this graph, it will extend by 5 dots as for the future years. The first dot is 2021 and followed by the other 4 years. As we can see, the trend of this graph continuously drop until the minimum point is at 2022 years, and it will increase very drastically until it reached the maximum point at 2025 years. I'm also implementing logistic regression to this dataset. This code employs logistic regression for binary classification to predict the popularity of music tracks based on all the selected features. It creates a binary popularity column, splits the data into training and testing sets, standardizes the features, and trains the logistic regression model. The confusion metric is then calculated and visualized using a heat map to assess the model performance in predicting track popularity. After running the code, we get the true positive is 94, the false negative is 243, the false positive is 76, and the true negative is 516. Based on the confusion matrix, the logistic regression model performs well in identifying non-popular tracks, true negatives, but struggles with correctly classifying popular tracks, leading to a notable count of false negative, while the number of true positives is decent. There's a room for improvement, particularly in reducing the instances of false negatives, which would enhance the overall accuracy of the model. Next, I also calculate the value of accuracy, precision, sensitivity, and F1 score. After calculating, the logistic regression model achieved an accuracy of 65.66%, correctly predicting track popularity 2/3 of the time. Precision stands at 55.29%, indicating that when the model predicts a track as popular, it is accurate around 55.29% of the time. However, sensitivity is relatively low at 27.89%, highlighting the model's challenge in identifying genuinely popular tracks. The F1 score, balancing precision and recall, is 37.08%, suggesting a room of improvement in achieving a more balanced predictive performance. That's all for my presentation. Thank you, Doctor.